My name is Prof Koshizuka from University of Tokyo, and I have many slides. I think the number of slides is about 60. so I must say 60 times next, please. So the first slide, please. Yeah, I'm a professor of the University of Tokyo, and I'm working in the Inter-Faculty Initiative in Information Studies of the University of Tokyo. Our faculty department is the Inter-Faculty Department. The many professors from the computer science and data science, and also the lawyer and the economists. Many kind of professors we have. And next, please. Next. Yeah, this is the profile, so next, please. Next, please. So my research topic is IoT, Internet of Things, because my boss, my professor is his name is Professor Sakamura. He has started the Tron project. Tron is the real-time operating system nucleus. The Tron project has started in the 1983 or 84, and I have joined the project in 1988. The ultimate goal of the Tron project is to build a IoT or ubiquitous computing environment. At that time, we did not have a terminology of the IoT or ubiquitous computing. At the time, we call this kind of system the highly functionally distributed system or computer everywhere environment. I think this is very Japanese English, I think. And this is our ultimate goal, or picture of our ultimate goal in 1987, about more than 30 years ago. This kind of environment is our project ultimate goal. So we are researching the IoT for more than 30 years with many industries or government or other international partners. And next, please. And our main result of research is operating system for IoT or ubiquitous computing. The iTron, industrial Tron, or recently we call this kind of operating system T-kernels. T-kernel means the Tron kernels. We have developed this very small footprint real-time operating system for IoT. This kind of small devices, this is a major device for the IoT, and we are developing the operating system for this kind of small devices. So next, please. So our operating system is open source software, so you can download anytime from anywhere from the website of our source code of our T-kernel operating system. And now I think more than 100 countries, from more than 100 countries, our operating system was downloaded by many countries or many companies. The next, please. And now the market share of our Tron operating system in Japan, I don't know the international market, but in Japan, about more than 50% or 60% of the real-time operating system market is our Tron. So I think for example, this room, we have many electronic devices, and most of them are controlled by our Tron operating systems. Next, please. And we have many partners. I think about 1,000 of company or organizations supporting our project. So this is a list of our supporting company. And next, please. This is also. So next, please. Yeah, for example, so many consumer electronics equipment, for example, the AV equipment or office equipment, like this kind of equipment are all application of our Tron operating system. Next, please. And recently, our operating system used in the spaceships, like this Hayabusa or Akatsuki made by the JAXA, Japan Spaceship Organization, are using our Tron operating system. So these spaceship all controlled by our Tron operating system. Next, please. And also, this is rocket Epsilon 1. This is a very consumer-based, very cheap and low-cost rocket developed by JAXA. This is controlled by our Tron operating system. So next, please. So today, my talk is about IOX. We are proposing the concept of IOX. IOX means Internet of Wildcard, X, blah, blah, blah. So this is because, next, please. IoT have many applications. So IoT, currently we are researching or using the IoT, and next we are proposing IoX. So next, please. So this is because now the Internet of Things, this is IoT, but many applications, so Internet of Places, Internet of Services, Internet of Abilities, Internet of Finance, Vehicle, Healthcare, Agriculture, many applications we have. So we are proposing that all of these are Internet of X, IoX, we are proposing. So from now, I would like to introduce, for example, three typical applications of IoX. The first one is smart building, the second one is public transportation, and the third one is agriculture. And after that, I would like to discuss two issues for IoTs. For example, this is a smart building application. This is a building of my laboratory, very new one, and this building was designed by the Professor Kengo Kuma, a very famous architect. And this is a very, I think, beautiful building. But this is not only beautiful, but also the intelligent building. Every facility in this building are connected to the Ethernet, and we can control everything by using the REST API. So we can control everything using Python program or such kind of program, so we can control everything. The next, please. For example, the many sensors or location system or control system, lighting, air conditioner, elevator, everything is controlled by REST API. And also we have many sensor systems, temperature sensor or humidity sensor, human sensor, and also a smart power meter or image sensor, weather sensor. We have these sensor and the control system are all connected, all facilitated in our building and connected to Ethernet. We can control everything from the network. Next, please. And this is typical devices of our building. And next, please. So our student in our laboratory or in our department, everyone can develop application for controlling this building. For example, this is a sample application by student to controlling our campus building. Next, please. This sample code program, I think more than me, all of you are very familiar with this kind of code. And next, please. This is, I also developed this application, and this is a controller of our building or my professor rooms. Because this is intelligent room, so intelligent building, so our room do not have a remote controller, physical remote controller in my room. So if we do not develop this kind of application, we can not switch on the light or switch on air conditioner. So we must develop application to live in this building. So next, please. The next topic is transportation, public transportation. That's a very small IoT system because just inside, only inside of the building. But next one is a very large level, city level IoT. We are dealing with public transportation open data center. Sorry, this is Japanese. But very simple figures. For example, in Japan, there are many public transportation. For example, the railway and bus and some kind of taxi or airplane. All data, timetable or real-time location or facility map, such kind of all data are collected into the one open data center. This open data center is operated by our laboratory or some organization. And this data is open to application developers, many application developers. So they develop the many applications. This ecosystem is a public transportation open data ecosystem. We are establishing this kind of system. The next, please. Oh, this is a real-time location of the JR East train. Red dot is a place of the place of trains. We can get this position using the IoT technologies. And and using this data, we are doing the open data challenge. This is a hackathon or ideathon for using open data or public transportation. And next one. And this is a winner of the last competition, Tokyo Trains. This application is very, very big, good application because this application can show every information in Tokyo, public transportation information in one application. So this is a winner of the last competition. So if you want to tackle with this challenge with this this event, please register. Make registration yourself in this website of our open data competition website. The next, please. The third one is agriculture. The next, please. We are now researching with people of Kochi Prefecture. This is a very, very big tomato 畑っていうことなんて言うんだplant. So next, please. Very, very big. Yeah, this is the inside of tomato plant center. Very big, big, big house. And many, many tomatoes here. And this is all controlled by IoT technologies. Very, very smart house. The next, please. We are measuring data, CO2 or temperature or humidity by using this sensor. And next, please. We can control the computer control the feeding of water. Next, please. The computer control the feeding of the CO2. This kind of intelligent, and this is the data from the sensors, and we can control such feeding on the basis of this data. The next, please. This is also, yeah, this is next, please. And next, please. Next, please. This is a graph of such kind of data. So next, please. So I would like to discuss about from now the two things, two issues from now. The first one is IoT process changes. Next, please. So, for example, using IoT and sometimes AI or data science in the company or in the many places, and we can find a good solution for real problems using IoT or AI. So next, please. So after that, what is the next step? Finding the good solution. And after what is the next steps? Next, please. I think change. Next, please. After finding the solution, we must change services. We must change businesses. We must change organizations. We must change the skill of workers. And so we must change everything. This is a result of the data science or IoT or artificial intelligence. Next, please. So the worst case is layoff. Some people must be laid off. So after that, what happens? Next, please. So what happens? So next, please. So everyone rejects the change. They do not want to have a change. They do not want change. So in IoT or AI or data science, next step, the most important thing is how to change. Or in the terminology of economics of research, change management. This is very, very important for IoT or data science. The next step of data science or next step of AI. This is one discussion. And last discussion, next please. Dismissing IoT, what this means. Next please. Question, what is the goal of IoT? What is the goal of IoT? So next please. My answer is dismissing IoT or deleting IoT or removing IoT. Why? Next, please. This is because typical IoT proof of concept story. Next, please. Yeah, this is very typical one. In IoT, measuring several parameters by using sensor or sensor networks, then we can get some data. So after that, we analyze the data using data science technology or AI technology. After that, the change or feedback happens. This is a typical story of the IoT solutions. And we are researching or trying this kind of process many times. So we can find the next, please. We can find many other parameters correlated with this data. So this is a result of data science or data analysis. After that, next please. The sum data, in this case, the data C, is very strong correlation with data A. And in this case, data C is very easy to observe in any cases. After that, what happens? Next, please. So, data C, then analyze and feedback. So, in this process, we need no IoT systems. Very, very simple solution. We can find very simple solution. So, next, please. So, this is a defeat or fail of IoT? I don't think so. Next, please. No, this is the most successful story, I think. The next, please. So from the view of a company, so next, please. I think the easier is the better. So good solution should, no. Before, yeah. Good solution should need no money and also no technology. I think this is a good solution. So the best solution is to do nothing. To do nothing is the best solution. So next, please. So the problem is not how to use IoT, but next, please. Yeah, so the problem is how not to use IoT. This is very important result. So, yeah, next, please. So this is very similar to these children are trying to start to ride a bicycle. This is a company, I think. And in the first stage, the child are helped by father, Papa. Papa helps him. I think this is a similar, the company were helped by IoT or AI. But next step, please. I think the Papa is leaving his hand, but the child do well. And, but he might know, he does not know Papa is leaving their hand, he might know. I think this is the best way of IoT or AI. So next, please. So IoT is not a system. I think IoT is not a system. Next, please. But I think IoT is a design framework or problem-solving processes. So next, please. So this is the final one. So the very, very ideal solution of IoT is not to use IoT. I think that IoT, not only IoT, but also AI and the data science, also very, very similar case. We are starting to use AI, but the research continues. Then the result or the final result is not to use AI or data science. This is, I think, ultimate goal or ideal result of AI or data science. Thank you very much.